Hello my dear students. Today I am going to discuss surface tension. In the previous class we understood the phenomena of viscosity, and we also learned to determine the viscosity by using Ostwald method, and we all solved some numerical problems and some factor affecting on viscosity. So in this class I am going to start surface tension. Before that, this property of surface tension is not new to you people. You've already come across this phenomena in your daily life. So before going to discuss, let us observe carefully these images. In the images we found that continuously the water drops which is pour on the coin which is on the floor. Here the water do not break up. The water drops do not break up, so we try to form a large water drops. So dear student, you please try to think the chemistry which is present in these water drops, and you also observe. So in the laboratory you observe that while delivering a liquid, a solution to another vessel by using a pipette, so the water droplets you have observed. So in that water droplets also it form spherical shape. The water drop is spherical. So why these spherical drops occur? So why water drops is sphere? So what is the force which is responsible for the spherical shape of the water? So the spherical shape means it try to occupy some minimum surface area. So why it is occupies minimum surface area? Okay, so let us look at another beautiful example which you can see in the nature, that in the lotus leaf you can found that if you pour the water on the lotus leaf, it is not flow like a normal leaves. Instead of that, it is converted into a temporary spherical water balls, and the water balls are rolling on the lotus leaf. So this is also an example for adsorption as well as surface tension. So why this surface tension takes place? So why water form spherical drops on the surface, and why it form spherical drops so while delivering from one system to another system? So why? Because there is a difference in the property of water which is present inside the vessel and which is present at the surface. So why the property of surface is different from the property of a molecule which is inside the vessel? Let us consider a vessel which contain water. In this vessel, the water which is present in this position. So in this position, the water molecule which is surrounded this central water molecule, and all the water molecule which is interact with this, and the net force of this water molecule is zero. That is this water molecule. Let us consider the water molecule which is present at the center, in which it is surrounded by many number of water molecule. All the water molecule interact with you, or there is a van der Waals force of attraction between the water molecule in all the direction. That's why the net force which is acted on this water which is present at the center is zero. But if you consider the water molecule which is on the surface, or which is in the surface, so here in this case, so only the water molecule which is below that molecule, liquid particles, are interact. So like this, you just observe here. So in this case only, so interaction takes place downward. So force of attraction, only a downward force of attraction which is exist in case of a surface molecule, because there are no molecule here, there are no molecule to interact. So that's why, so these this is one layer, the last layer molecule, so downward pull, that means due to this force of attraction of So other second and third layer surface molecule, so there is a downward pull attraction of molecule takes place. This downward pull, this inward pull attraction is responsible for a spherical shape. So let us observe here. So this is molecules which are on the surface. Okay, so they are experienced by unequal forces. So here it is experienced, there is a equal force of attraction in all the direction. But in this case, so only the inward pull of attraction, so by second layer molecule which is just present just below the surface molecule, so these are responsible for inward pull. So this inward attraction is responsible for a spherical shape of the molecule. If the inward pull is more, so the spherical shape is more, and that is it occupy minimum surface area. So the capacity of a liquid, it occupy a minimum surface area is called as surface tension. That is a force which is acting on the surface molecule, and as a result, so the water molecule turns into drops, or on the surface it is converted into a spherical shape. So this phenomena is called as surface tension. So the surface tension can be systematically defined as the force in Newton which is acting right angles along the surface. So right angles, you see here, right angles along the surface of a liquid of 1 meter length. So this is called as surface tension. And the surface tension also responsible for the what? It's responsible for a capillary action. Capillary action. You know capillary action. So if you put capillary tube in any water, so at that moment upward movement of water takes place. But actually for the upward movement we have to supply energy. But in case of capillary tube, so spontaneously upward movement takes place. This upward movement is due to surface tension. So now you understood surface tension. Next is surface energy. Just observe this diagram. If you really observe this diagram, and if you notice the changes takes place in each step of this diagram, so really you can understand this surface energy. And in this diagram what happened, so in this molecule which is present at the top, so this is the actually graph. So in the x-axis is the surface tension, so magnitude of surface tension versus surface energy. So in this case the surface energy is more, but here surface energy is less. But here surface tension is more, so but here surface tension is less. So you just observe here. So here in this molecule, the surface area occupied by molecule is less, but here surface area is more. Here surface area is even more. Here surface area is increases, and the water drops are not spherical. So instead of that it is a semicircle, half circle, and so here almost flat. Surface area is more. So why this is happens? Why the surface area decreases? Okay. So now you have to know the relationship between surface tension and surface area. If the surface tension is more, the surface area is less. Okay, if the molecule possesses more surface tension, that is surface tension is due to force of attraction. If the force of intermolecular force of attraction is more, surface tension is more, and this surface tension is more, it occupies minimum surface area. So now you understood that surface tension, it is inversely proportional to surface area. In this diagram, so here surface tension is very high, that's why surface area is very less. Here surface tension is very less. You observe here surface tension, you look at the graph, surface tension is less and surface area is high. These two are inversely proportional. And this surface tension is directly proportional to interliquid particle attraction. So now you understood. Now surface energy means, so if you suppose this is the water, okay, this is the water drops. If you supply energy, thermal energy to this system, at that moment its surface energy decreases. Why? Because here the attraction is more, that's why surface tension is more. If you supply the energy, the interparticle attraction decreases As a result, surface tension decreases. If surface tension decreases, the capacity to occupy minimum surface area is decreases. As a result, so its surface area is increases. So that's why surface area is high here, surface area is high, surface area is increases. But look at the surface energy. Here surface energy is high for this. Okay, surface energy, yes, see the surface energy is high, so its surface area is also high. So surface tension, it is inversely proportional to surface area. Surface area, it is directly proportional to surface energy. Then surface energy, it is defined as, so the work that is required to be done in order to extend the area of surface of a liquid by 1 square meter, it is called as surface energy. That means if you apply the surface energy, that is energy to the system, at that moment the shape of the water drops reduces, the spherical shape becomes half sphere, finally flat, that is surface area is increases, so surface tension is vanishes. So this is called as the amount of energy required to minimize the surface tension or to increase the surface area. So this is called as surface energy. So usually this surface energy can be expressed in terms of joules per mole. So now let us see some of the factor which is affecting on surface tension. So one important factor is temperature. So dear student, just now we understood so the relationship between temperature and interparticle attraction. So you know that the kinetic energy which is directly proportional to temperature. If temperature increases, kinetic energy also increases. So if kinetic energy increases, what happens? The intermolecular force of attraction decreases. The intermolecular force of attraction decreases. So if intermolecular force of attraction, the surface tension also decreases. Thus, this temperature, it is inversely proportional to nu. That is, nu is a symbol, it is used to indicate surface tension. So temperature, it is inversely proportional to surface tension. If temperature is more, surface tension is less. So at critical temperature, the surface tension is 0. So in the kinetic theory of gases, you understood the critical temperature. Then second important factor is so effect of solute on surface tension. Okay, for example, a number of substance when added to water, it lowers surface tension. So these substances are called as surface active agents. So they may reduce the force of attraction. For example, the liquid like methanol, ethanol, acetone and acetic acid. So when added to water, they are lower its surface tension. Similarly, soaps and detergent when mixed with water lower its surface tension. That means so they are reduce the formation of spherical drop of water. See, so the water bubbles is not surface tension. It is completely different. Surface tension means water should form a spherical shape, a drop shape, okay, or it converts into drop. So behind there is a force, that force is called as surface tension. But here some of the solute, so which are going to decrease the surface tension, so these solutes are called as surface active agent. Example, methanol, ethanol, acetone. So these are going to increase the surface energy. See, if sir, as you know in the previous slide we understood, if surface energy is more, so obviously surface tension is decreases. So I think this is because in case of water there is a strong interparticle or hydrogen bonding is present. But if you add these substances, these are going to break that interaction. As a result, surface tension is decreases and gradually surface energy is increases and they occupy more surface area. So this is how the temperature and the solute affect on surface tension. So in the next video, I am going to discuss the determination of surface tension.